Hello, pre-algebra friends. We are starting chapter 5, and I need you to have your book open to page 221. So there is a bunch of vocab in this unit, and that's why I need you to have your book open. We've talked about integers, we've talked about whole numbers and counting numbers, natural numbers, and we're going to review all of that, but we're introducing a new type of number, a rational number. So you can see the definition of a rational number. It's a number that can be written as the quotient, that should tell you division, the quotient of two integers. And we'll review what integers are. They are counting numbers, they're opposites in zero. So basically, rational numbers, this big math vocab word, is just another term for the word fraction. A fraction is the quotient of two integers. It has a numerator and a denominator, and it's got a fraction bar in between. So if you are looking at a fraction, you are looking at a rational number. So rational numbers, fractions, can also be turned into decimals, and you guys are used to doing that, dividing the numerator by the denominator. You do that when you get your scores on assessments from me, tests and quizzes. You divide, you have a fraction at the top of your page, you divide the numerator by the denominator, and you get your percentage. So there are two types of fractions. They either turn into a terminating decimal or a repeating decimal. And there is a third kind of decimal, and we'll talk about it in a second. So examples, a simple example of a terminating decimal, 1/2. It turns into 0.5 and it stops. A repeating decimal, 1/3. It turns into 0.3, but the 3 repeats forever. So we write it like this. A third type of decimal is one that cannot be written as a fraction because it does not terminate, it does not repeat, and the most famous of these is pi. So pi, we know, is 3.1415, and on and on and on. It never ends, so it never terminates, and it never repeats. So unlike 0.3 repeating, it never ends, but it's repeating. These non-terminating, non-repeating decimals cannot be written as a fraction. So I want you to look at the drawing on the bottom of page 221. They do a Venn diagrammy kind of thing of whole numbers and integers. And I want you to copy that. And we're going to talk more about it and these types of numbers when you come to class. So go ahead and pause the video, copy that drawing from the page that shows where the overlap is, and then join back up after you've done that. So these are some simple examples of writing numbers as rational numbers. So it says, show that these numbers are rational by writing them as a quotient of two integers. This is not a quotient of anything. He doesn't have a numerator and a denominator, but we can make him a rational number by simply drawing the ghostly 1 as the denominator. And on this one, negative 100 over the ghostly 1. This isn't the quotient of two integers. This is a mixed number. So we're going to turn him into an improper fraction first. And I put this negative out here because I want to talk a little bit about what you do with this negative sign. When you are turning it into an improper fraction, you ignore this negative sign. It's not 9 times negative 3. It's 9 times 3, and you add 7. And then when you write your improper fraction, you just put the negative sign in front of it. So 9 times 3 is 27, plus 7 is 34, and it's all over 9. And then this negative sign comes down here. It's not part of the calculation. Okay, I'm going to do a few of these. In years past, kids have a hard time remembering how to do long division. So we are going to practice, 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 practice. So when your numerator is smaller than your denominator, you know you're going to end up with a decimal answer. When your numerator is larger than your denominator, you're going to end up with something that's larger than 1. It may have decimal points behind it, but it's going to be larger than 1. So the numerator goes inside the house. That's terrible math vocab, but I don't know a better way to say it. The numerator inside the house. 5 doesn't go into 3. I add a decimal point down here and up here, and I add a 0. And I ask myself, does 5 go into 30? You bet. 6 times. 6 times 5 is 30. I have a remainder of 0. I am done. This fraction turns into 0.6 as a decimal, and this is a terminating decimal because it ends. Let's look at this one. All right, 106 goes inside the house, 5 on the outside. 5 doesn't go into 1, but 5 does go into 10. Bring down the 6. 5 goes into 6 one time. 1 times 5 is 5. Remainder 1. Now we need a decimal point, top and bottom. Bring down a 0. 5 goes into 10 twice, and we are done. There is no remainder. So again, this guy in decimal form is 21.2, and again, he is a terminating decimal. Let's look at this one. 2 goes in the house, 3 is on the outside. 3 doesn't go into 2. I need a decimal point and a 0. 3 goes into 20 6 times. It's 18. Remainder 2. Bring down a 0. 3 goes into 20 6 times. Are you seeing a pattern? So once you have decided that you are never going to get out of this division, you go back up here, you say, this decimal never ends, but he repeats. So this is the way you write it. You write the horizontal bar over the guy that repeats. And he is repeating. So we had 2 terminating and 1 repeating. Let's look at these couple more. 7 over 12. 7 goes in the house, 12 on the outside. 12 doesn't go into 7. I need a decimal point here and here and a 0. 12 goes into 70 5 times. 5 times 12 is 60. Remember, you get out of bed knowing that. Remainder 10. I need another 0. 12 goes into 100. Let's see. Not 7 would be 84. I think it'll go 8 times. That's 96. And if you have to go do some arithmetic on the side, you don't have to do it in your head. That's remainder 4. Bring down another 0. So I've got that one, and I've got that one. 12 goes into 40 3 times. 36. Remainder 4. Bring down a 0. 3 times. 36. Can you see the pattern? So this is never going to be ending. But not everything behind this decimal point repeats. It's only the 3 that repeats. So that's the only place I'm going to put that repetition bar. So this is a repeating fraction. And the last one on this page, 5 inside the house, 8 on the outside. 8 doesn't go into 5. Bring a 0 or add a 0. 6 times 8 is 48. Remainder 2. Bring down a 0. 2 times 16, or 2 times 8 is 16. Remainder 4. Go another time, and you get 5 with no remainder. So this is a terminating decimal, and it's 0.625. So we're going to do more practice on these. If you're not really good with this, you need to practice, practice, practice. All right, let's look at the next page. So now we're going the other way. I'm giving you a decimal. I'm asking you to write it as a fraction and reduce it. So we're going to reduce all of our fractions or our mixed numbers, and we're going to put them in simplest form. And that's what we did in chapter 4, was reduce fractions to simplest form. So how do you turn a decimal into a fraction? Say its name. So I know you say this is 0.78, but if mathematically speaking, this is 78 100ths. So that's how we turn it into a fraction. Now this is not in simplest form because I know at the most basic level 2 goes into both of those. So that's 2 times 39 and 2 times 50. Cancel the 2's. 39 is 13 times 3, and 3 doesn't go into 50, so this is the reduced fraction. Let's look at this guy. This is 1 and 24 100ths. So 124 100ths. And again, we got to just start reducing. Maybe you see a bigger number than 2, but you can always start with 2 if both numbers are even. So that's 2 times 62 and 2 times 50. I can already see I'm going to have to keep reducing because 62 and 50 are both even. So that's 2 times 31 and 2 times 25. 31's prime. 31 is not a multiple of 25, so I'm pretty confident we are done. Let's look at our last one. This is an interesting one. This is tens, this is hundreds, this is thousands, but you don't need this extra 0 on the back end. So you can just write it as 5 100ths. Now, if you went ahead and wrote it as 50 1,000ths, you're going to reduce to the same thing. So 5 goes into 100 20 times. So actually, we can write this as 5 over 5 times 20. And when your numerator cancels entirely out, you have to add the ghostly 1. If you just write 20 as your answer, that's incorrect. It's 1 over 20. All right, we're going to skip. We're going to skip number 9 for now. We're going to do a little bit more in class. I just want to run over number 10 really quickly, and then we'll be done with this video. So this is saying that at these townhouses, there are 52 total units, and 13 of them are vacant. So that means 13 over 52. 13 vacant, 52 total. At the second set of units, there's 148 units total, and 36 of them are vacant. It's asking which rental place has the greatest vacancy. Well, we are going to reduce these fractions to their simplest form, and maybe it'll be easier to compare them than it is now. So 13 over 52, 13's prime. I have to ask myself, however, is 52 a multiple of 13? And yeah, it is. 13 times 4 is 52. So if you reduce this fraction, the numerator is gone, so I have to add the ghostly 1, and this says 1/4 of his townhomes are vacant. What about this guy? Again, if you want to start with something higher than 2, if you see something higher, then do that. If you start with 2, it would look like this. 2 times 18 over 2 times 74. Cancel, cancel. I got to keep going. 2 times 9 and 2 times 74 is, let's see, what's 74 divided by 2? 37. Did I do that right? Let's see, 2 times, yeah. So cancel, cancel. And now you are comparing 9 over 37 and 1 over 4. Well, what would a fourth of 37 be? 9 times 4 is 36. So I am thinking that this is the larger vacancy right here, because a fourth of 37 is going to be not quite as big. 9 times 4 is 36, so I'm saying this one would be the largest one. So this is using simplifying fractions to compare fractions. We did this in chapter 4 some, and we're going to do it again and again, and we're going to learn another way to compare fractions actually in this chapter that I like better than this. All right, thanks for watching. We're going to skip number 11, and I'll see you back in class.